Hello there, welcome to this video lecture of the curvilinear motion of a particle. By using the kinetics, we are finding the different field parameters. In the last video lectures, we have seen different working concepts. At the same time, we do have developed the equation of dynamic equilibrium also we do have calculated. Now we will see some of the ideal conditions when a particle is moving in a curvilinear motion, the curved path. The path is going to be existed in the vertical plane. Already with that we have seen that we are trying to write the equation of dynamic equilibrium. Alright, so there we can see here, this is going to be your vertical plane and this is your horizontal plane. This already we do have a discussion in the last video lectures. Now there we can see there is going to be a curvature is going to be like this, the curved path. And this is going to be your center, and the radius of the curvature I am going to be taking the r we can say a rho also. Right, so then we need to find out the equations here. So can you see where is the weight of the system is going to be acting? That means it is acting vertically in the downward direction. That's going to be the W, right? And similarly, and we told that it is going to be constant velocity over here. It is going to be acting in this direction, right? At the same time, the normal reaction forces are going to be developing. As we know that the tangential components are going to be acting in this direction, and the normal accelerations are going to be always acting towards the center. That's already we do have discussion. So if I am going to be taking this going to be the free body diagram over here. So this is going to be your free body diagram, and there we can see this is going to be your particle. So can you see here the particle is going to be existed here. So if I am going to be draw the free body diagram of this one, this part I have taken extended. Self weight is going to be acting and G in the downward direction. Right, and towards this direction what is going to be acting? That is going to be your AN is going to be acting, and similarly, and towards this side there is going to be AT force is going to be acting. So there, and this is towards the center, and this is going to be towards the tangential direction. The self weight is going to be acting vertically downward direction. So from this one, what I am going to be writing over here equation. At the same time, the reaction force also coming from the part of this part. So that's I am going to be writing in the vertical direction. So that your reaction force, because it is going to be having a contact with the curved path, R I am going to be writing over here. So I am going to be taking here, what is the formula I am using? That's going to be sigma f of n is equal to 0, because this is the dynamic equilibrium we are going to be considering. Now can you tell me what are the forces are going to be acting in the direction of your normal direction? So there we can see R is going to be acting towards this side and AN is going to be acting towards this side. Then what it means, and this is going to be normal acceleration is going to be acting towards this side, but the inertia force is going to be acting opposite to that direction. That means your inertia force is going to be acting this whole direction, and AN we are going to be getting. So if I am going to be simplifying this equation, R is the reaction force minus mg is going to be the self weight of the system acting in the downward direction, and inertia force acting towards this side minus MAN is equal to 0. And these equations we are going to be calling a dynamic equilibrium equations. So can you write down for this part how we are going to be developing this concept? So now come to this point. The same I am going to be drawing over here, and your particle is going to be existed in this position, right? So the self weight is going to be acting always vertically in the downward direction. At the same time, it is going to be contact with the rigid surface, so then your reaction force is going to be acting in this direction, right? And where is your normal acceleration is going to be acting? That's already we told, it is acting towards the center direction. That means your normal acceleration acting towards this side, this is going to be your AN. But your inertia force is going to be acting in which direction? That's going to be opposite to this direction. This is going to be your MAN I am going to be calling. Right? If I am going to be writing the equation, that's going to be sigma Fn is equal to 0. So then what is the formula? R is acting vertical direction, your inertia force acting vertical direction, your mg acting in the downward direction. So that's R minus mg plus man is equal to 0. So can you see the difference between when it is going to be moving towards this side and when it is going to be moving in the climbing the hill or going in the deep valley? So the difference of these equations we can find out here. The inertia forces are going to be little in the opposite direction. This is going to be in the vertical plane because we are using the constant velocity. When we are using the constant velocity means at is equal to dv by dt is equal to 0 we are going to be considering. That's why in this case the tangential acceleration we are not going to be considered. So now we will see the motion of a particle with a constant velocity in a curved path. It is in the horizontal plane. In the last video have seen that is in the vertical plane. Now we shifted to the horizontal plane. As for the working concepts we have discussed, the same points we are going to be using to formulate the equations of dynamic equilibrium. So there we can see the particle is going to be moving in this one. I am going to be taking, this is going to be your free body diagram, and there we can see here. This is going to be your particle P, suppose if I am going to be saying. So then in this case what will happen? This is going to be your center C we are going to be say, and the radius of the curvature I am going to be say the small r. Now can you tell me where is the self weight of the system is acting? It is acting vertically in the downward direction. Alright, so that means this weight is going to be acting normally to the plane of motion. Alright, so then we can see here the particle is going to be trying to move in this direction, suppose, and this is going to be your velocity, right? The self weight is going to be acting in this direction, and the reaction force is going to be acting towards this side. This is going to be the reaction is coming from the hard surface, and your normal acceleration is going to be acting towards this side. This is the an. Already we have discussed an always acting towards the center. So that's an we are going to be calculating v squared by rho r we are going to be considering. Now, but the normal acceleration is acting towards this side. In this case what will happen? The inertia force always acting opposite to this part, and that I am going to be taking m into an. If I am going to be writing this equation, I am going to be omitting the weight in our equation, right? That I am going to be writing r minus m an is equal to 0. This is going to be your equations of dynamic equilibrium. Then where is the component of the W? As you know that this is not going to be valid because the particle is moving in the horizontal plane, but the forces are acting vertically downward direction. We are not going to be considering. Already we have discussed that part. I hope you are able to understand when a particle having a constant velocity, it is moving in a curved path. The curved path may exist in the vertical plane or may exist in the horizontal plane. So then what will happen in this case? According to that, the normal acceleration and the self weight of the system and the reaction forces, these are what the forces are going to be acting. That I am going to be taking sigma Fn is equal to 0. Alright, by using the summation of the forces which are in the normal directions, and then we have derived these equations. The same equations we are using further in our problem also to solve the problems. So I hope you are able to understand the concepts what we have discussed over here. And still you feel any confusions or any difficulty, and please put in the comment section so that I can reach out to you. For better understanding, you have to see and you have to follow the series of video lectures, and with that discipline your mind will going to be more matured. Thank you, all the best.